Creating a homemade railgun, is it possible? So, what's the deal with railguns? Simply put, a railgun is an awesome piece of technology that uses electromagnetism to launch projectiles at super high speeds, and they've been catching a lot of attention lately. Imagine a futuristic weapon that doesn't rely on traditional gunpowder. Today, we're going to explore whether it's actually possible to create a mini version at home, along with some cool science behind it. Ready to dive into this electrifying project? Let's go. Safety considerations. First things first, safety. When you're working with anything that involves electricity, it's crucial to put your safety first. Always wear gloves and goggles to protect yourself from potential hazards. Set up your workspace in a dry, well-ventilated area away from flammable materials. Remember, we're going to be dealing with high voltages and currents, which can be dangerous if mishandled. So stay sharp, keep your space tidy, and make sure you understand each step before jumping in. Safety is key to having a fun and successful experiment. Basic physics concepts. Now, let's break down the basic science behind railguns without getting too bogged down in technical jargon. At the heart of it, railguns operate on the principles of electromagnetism. Here's how it works. When an electric current flows through the rails of the gun, a magnetic field is created. This is where the Lorentz force comes in, basically. It's the force that acts on charged particles moving in a magnetic field, which in our case is what propels the projectile forward at mind-blowing speeds. Think of it as unleashing a burst of energy that sends your projectile flying. Additionally, having a basic grasp of voltage, the force driving the current, the flow of electric charge, and magnetic fields will help you appreciate what's going on. Exciting, right? Materials needed. Ready to get crafty? Here's a quick list of materials you'll need for our electromagnetic coil project. Gather some copper wire, a battery pack, preferably a 9 volts, a non-conductive base, like a piece of wood, and a few metal rods to act as projectiles. You'll also want some electrical tape, wire cutters, and possibly a multimeter if you want to check your current. Most of the supplies can be found at your local hardware store or online. Make sure you have everything before we start building. Constructing the electromagnetic coil. All right, let's get to the fun part: building our electromagnetic coil. Start by taking your non-conductive base and positioning it where you'll be working. Then, take your copper wire and coil it tightly around a section of the base, forming a solid loop. Aim for at least 50 turns to create a stronger magnetic field. Once you've achieved enough loops, secure the ends of the wire using electrical tape. Next, strip the ends of the wire and connect them to your battery pack. Make sure you're connecting the positive and negative ends correctly to avoid any issues. To test if your coil is working, you can use a small metal object. When you apply power, you should see the object being pulled towards the coil, indicating that you've successfully created an electromagnet. If this doesn't happen, double-check your connections and winding. One last tip: be mindful of your wires. Don't let them touch or cross over. It can cause a short circuit. Testing the coil. Let's see if our coil is up to the task. Carefully connect the battery and observe how it works. If everything is hooked up right, you should see your small metal projectile shooting out with a decent amount of force. It's really impressive when you see it in action. If your coil doesn't seem to be performing, there might be issues with your connections or the winding, so revisit those areas. Don't get discouraged. Experimenting is part of the process. So, that's a wrap on our adventure into the world of homemade railguns. While it's a thrilling project to undertake, remember the importance of safety and responsibility when experimenting. Hopefully, you've gained a new appreciation for the science behind it. Keep exploring, and who knows what you might invent next.